Esmond Lee is a fifth-year PhD student in stem cell bio at Stanford. He's originally hails from Singapore, which is very far away, and went to undergrad at University College London, which is also very far away. And he came to Stanford, and since then he's been integral as a member in the Stanford InterVarsity Graduate Fellowship, Ivy grad. He's been a leader in the International Bible Study. He's been worship coordinator. He's helped out in many different small groups in many different roles. And he's also this year been we call him the Dean of Students for the NorCal region. So coordinating interfellowship events and kind of interactions like this one for the various InterVarsity fellowships in the Northern California Pacific area. So yeah, he does a lot. Outside of that, he's also, so he does research in stem cell immunotherapy methods, but also does a bunch of things with IV, plays guitar in Cajon, takes singing classes on the side, does rock climbing, volunteers at Street Life Ministries, cooks, and somehow, I don't know how, finds time to sleep in between all of that stuff. So we're very excited and very privileged to have him to speak with us, and I will turn the floor over to you, Esmond.
Thanks for the kind introduction. So, as Nathan mentioned, I was originally from Singapore, and I am still from Singapore. I just wanted to introduce my family and home. It's a small country, about the size of between where I'm at in Menlo Park and San Jose-ish, I would say. And Singapore came to prominence as a British port, and you can see that from China, you need to pass through this strait through Singapore to get to Africa and Europe. And so it was very important geopolitically, and still is today. There were lots of opportunities, and so similar to the United States, it's a nation of immigrants where people were originally from different parts of the world. We have about 5.5 million people and are the second most densely populated country in the world. First is Monaco. And Singapore has the same population as Scotland, but it's about 100 times smaller. And one of the unique things about Singapore is that despite the density, it is also known as a garden city, and there are beautiful forests and trails. In fact, this is a view from my home, and if any of you would like to visit, or please let me know. I would love to show you around or let you know where to visit. Yeah. If any of you have watched Crazy Rich Asians, which was set in Singapore, I also want you to know that my family is nothing like that. This is a photo of my favorite people in the world. It was Chinese New Year last February, and since I was away, I appeared in an iPad, and my sister was pregnant at a time in May. We had another addition to our family, and so now I'm an uncle, and the bottom right is me and my mom on a hike near our place. So now my life in California, I fell in love with California and the Bay Area when I visited and started grad school in the fall of 2016. As part of the Ivy Grad Fellowship at Stanford, I've been part of the IBS small group. You can see our gathering during pre-COVID times, and even in the pandemic, life goes on. And here you can see us celebrating a friend's wedding on the left, and on the right was Junen's birthday this year. And I think it's interesting how we've still been able to grow in community despite being apart physically. And in many ways, it's the same with the interchapter events that we are having, including the one today hosted by Veritas. And with that little introduction about my home and family and when I came here, I want to share with you about my academic journey as well. So I'll share a little bit about what I do at Stanford. I'm a PhD student in stem cell biology and regenerative medicine. And what exactly, though, does stem cells mean. When we look at how our body is formed, we think of cells that kind of organize into tissues which form organs, and then each organ plays a particular function. And stem cells are, in fact, in charge of replacement in your body. And when your cells become aged due to injury or um, just the natural kind of death. And we just think about your hair or like our intestinal lining that replaces itself every 5 to 7 days. We kind of all need that kind of replenishment in our body. And this is the picture of the Milky Way that I showed previously, and that was taken at Russian Ridge. Another one of the things that I really love about California is nature and outdoors. And if you look at that disk, there's about 100 billion stars there. And every day, the stem cells in your blood also produces ballpark the same number of red blood cells. And that's really amazing to me. So there are different organs in the body, and each organ has different kinds of stem cells. And today my talk will focus on blood, or the hematopoietic stem cell. In addition to red blood cells, the hematopoietic stem cell also produces platelets that help you to clot, and immune cells that allows your body to fight infection. While normal cell types can last for weeks or months, stem cells, or blood stem cells, they reside in the bone marrow and they persist throughout your entire life, and they supply you with blood. I think what's also amazing to me is that each of the cells in our body, even though they have the same genetic makeup, they can perform different roles. In the cell, it is the turning on and off of genes in an orchestrated fashion that allows the cell to perform its function. But if there's like one instrument or one entire section that is out of tune or off by a bar, then the beautiful piece can then start to sound a little dissonant or even painful to the ears. Likewise for genes. So these are two kind of well-known examples of genetic blood diseases that you may know of. The first is bubble boy disease, whereby mutations cause immune cells to lose function. So the kids can't fight infection, and they need to live in a sterile bubble to avoid getting sick. And the second is sickle cell, whereby the mutation causes hemoglobin misfolding, leading to sickle-shaped red blood cells. So if we were to figure out that the reason our orchestra is sounding a little off is because the first trumpet didn't really practice, we can either make sure that he gets more practice, or we can replace him with a better trumpeter. That is exactly what we're hoping for in stem cells and regenerative medicine. In science, we've only very recently discovered ways to go into the genetic code of cells and to make modifications that can help us to repair its function. And of course, this is what I'm talking about is CRISPR-Cas9 that was discovered by Jennifer Doudna and Emmanuel Charpentier, and they won this year's Nobel Prize in Chemistry. So the approach that I'm exploring in my thesis project is to combine our understanding of these two kind of concepts of stem cells and gene editing with CRISPR-Cas9 to help those with the genetic blood disorders. We aim to obtain patient stem cells, to insert a corrected copy of the defective gene that they have, and then return the corrected stem cells back to the patient. And some of those therapies that at Stanford have already been approved for a clinical trial. For example, the disease that I talked about, sickle cell, trial from the Porteous lab has started. And on the right is my PI, who is a clinician scientist. Next to her is a patient who suffers from a genetic immune disease that we are working on. So just a plug for not sure if any of you, how many of you voted recently, but whether to fund stem cell research was one of the things up for a vote, and I'm happy that most Californians, it appears, voted yes. So stem cells going to be continue to be funded in California, and of course this will enable more therapies that I've described to reach patients. So that's all well and good, but of course, every tool can be used as a double-edged sword. And there was an infamous incident in 2018 where CRISPR, the same technology to cut and to manipulate genes, was used to manipulate the genes of unborn twins without good medical justification and without a proper review process. And there are also various biohackers trying to encourage people to use CRISPR DIY style. So one of the questions that I had when all these things arose is, should we use gene editing for enhancement? Are we trying to play God? How should I think of my Christian faith and use that as a lens to understand what I'm working on? So there's quite a number of these questions that sort of accumulated during my time as a PhD student. And at the back of my mind, I was always thinking how my faith can provide this lens. And in 2019, I visited a very special place. Any of you know where this is? It is the Capitol building, and it's where the U.S. Congress meets to decide on legislation. And when I went in there, one of the wings of the Capitol is called the Brumidi Corridors. This is just a beautiful, it almost looks like just wallpaper at first. But if you look closely, every wall in there was painted differently. It was one of the most beautiful insides of a building that I've seen. It was painted with birds, plants, and scenery found during a geological survey of the United States. And was constructed in the 1850s, but the architect Brumidi also left space for other events. So, of course, the moon landing didn't happen in the 1850s, but he left kind of blanks there so that people could fill in other important and significant events in U.S. history. And so each wall is really bright and beautiful until you come to the end of the exhibition. And at the end, there's a corner part of the wall that's really very dull. And what had happened is that over the years since the 1850s, there were layers of dust that had built up. People used to smoke in the corridors. It was a buildup of dirt that causes these paintings to become dull. So they decided to start a restoration project that was complete only in 2017. So I thought that, when I saw this, that I began to see how it was an analogy to the work that we're trying to do with CRISPR and with the medical profession as a whole. We're not here to change the image or I don't like the way they drew this thing. I want to add another arm or another branch to this tree. It's not to criticize, but to make the original painting shine bright again, and to have its colors and its vibrancy displayed for everyone to see. And to me, it was a reminder that we're fearfully and wonderfully made by God, and our role is to really restore people who are sick to live healthy and vibrant lives. So some of the lessons that I learned are that human biology is complex and beautiful. And the second thing I learned was a framework to help me understand the work that I was doing. And is that the case for human biology and medicine is to restore rather than to improve or change or enhance. Well, this is debatable, but that's my take on it. And the third thing I've learned as a fifth-year kind of cynical grad student is that, despite our best efforts and intentions, or what the field proposes is the intention, there's still a lot of fallenness and imperfection within the system. There's pride and academic ego, the desire to appear well put together and to sound smart all the time. There's also an unhealthy work-life balance. And if I'm not careful, I can also start to reflect the culture that I find myself in. And I've had to catch myself many times where I've put my trust and confidence in things that I could that could earn to feel good about myself, but are ultimately empty, or during times of overwork because I'm insecure about not having generated enough worthy data. But it's really Christ who chose me, gave his life for me that I may live, and I have seen how he has given me peace and confidence in exchange for my brokenness. And it was a calling to reflect him and his kingdom values rather than to reflect the culture that I found myself in. So these are just three reflections that I had, and some questions for discussion later. But before that, I'm going to stop sharing and take any questions.